For our project, we made a air cannon, as you can see right here. Also, one of our goals was to create a GUI tool that would allow the user to input any distance, and the GUI would output an angle that we could then adjust our physical build to model what our equations would give us.
We used Euler's method to calculate the acceleration and velocity of the projectile at each point in the barrel. The sum of the forces acting on the projectile was used to calculate this acceleration. This included the force of pressure, the force of friction, the force due to wind, and the force of gravity. This was able to help us calculate the exit velocity of the projectile as it left the barrel. This exit velocity was able to be used in the calculations to find the distance that the projectile would land, and this was then, in turn, used in a battleship style to calculate the angle which the barrel would need to be elevated to in order to reach this maximum distance.
To go through the actual physical model, we have our cannon here. It works, you take a bike pump and we can pump into our pressure chamber, 15 psi usually, and then we have our pressure release valve which releases the pressure through the barrel, launching our projectile. It's also adjustable. We have 4 different angles available. So you would pull out this dowel here, slide it up, and set the dowel into a new hole, adjusting the angle.
So here is our graphical user interface tool, our GUI. So as you can see here, you can change your distance for your set target by either inputting manually on your keyboard to any set distance or using the slider right here. After choosing a distance, let's choose about 15 meters. 15 meters, press launch, and it'll display the animation of the projectile in motion. If you want to run some numbers pretty fast and just get all the data you need, you can turn animation off for a smoother and faster approach to collecting data. Here you can change it again to a distance of 13 meters. Press launch, and it'll display the angle of degrees that you need for that set target. Also, the pressure variant can change within the code if you want to go above or below 15 psi. Here is our physical build in action.
In order to see how accurate the physical model was compared to the computational model, we set the cannon to be launched at 5 different angles. We then measured the distance from the cannon where it was launched to where the ball landed, and compared this distance to the theoretical distance at a given angle in the computational model. We were able to compare these distances to get a percent error of 41.3%. Possible sources of error could be due to the wind that was not accounted for in the computational model, the measurement of volume in the chamber, and the time it took to release the pressure into the barrel, which we assumed to be 0.
They all know my sound.